Greetings and welcome, friends. Today we're going to combine our knowledge of conics, so circles, ellipses, hyperbolas, parabolas, and our knowledge of solving systems, right? Simultaneous equations with unknowns, right? And we're going to combine those two things, and we'll be able to find, say, what's the intersection between two ellipses. And why would that be valuable? Well, if you wanted to figure out, is planet Earth and its elliptical path ever going to collide with a comet and its elliptical path, right? That would be worth knowing in some cases. However, I guess in that case, that would only be part of the story, because if the path of planet Earth coincided with the path of a comet, it's not a problem as long as they don't inhabit that same space at the same time, right? Like I crossed the street this morning, and maybe some of you drove that same street this morning, so our paths intersected, but hopefully I didn't intersect with your vehicle because we weren't there at the same time. But today we're going to talk about systems of conics, and before I get there, let's talk about finding the intersection between a line and a conic, which is something that we saw alluded to in the kneecap question, the previous little video that I just posted. So let's do that. Let's find the intersection. So let's just jump right in. Intersection of the following two equations. What if I've got, yeah, I like it a lot. 3x squared plus 2y squared minus 54y minus 143 equals 0. And the equation of the line, x, yeah, I guess I'll do that, minus 3y minus 3 equals 0. That's the equation of line in standard form. Ax plus by plus c equals 0. Sometimes it's equal to c. But nonetheless, let's define that. So this is a line right here. So this is a line. And does anyone know what kind of conic this would be? Well, it's got two types of squared terms, so that means it's not a parabola, because a parabola would only have one. The signs of these are the same, so that means it's not a hyperbola. The numbers of their coefficients are different, which means it's not a circle. So it must be an ellipse. Okay? Now, before we even try to figure this out, let me ask this question. How many intersections could a line and an ellipse have? 2. Okay, so it could have 2. So if I have an ellipse and a line, right, it could intersect at 2 locations, right? That makes sense. Could it intersect at 1 location? Yep, if I happen to have a line that was perfectly tangent, all right, it's possible to have 1 intersection. Is it possible to intersect at no locations? What if I have a line like this? Right? So it's possible to have no intersections, 1 intersection, or 2 intersections, right? So that's I don't even know if this is a horizontal or vertical ellipse right now. It actually doesn't matter to me. Unless I wanted to graph these, I guess I could do that and try to figure out if they have any intersections. If I have technology, it would kind of give me a pretty good approximate of it. But let's solve this another way instead. Now, let's see. I technically only have 2 variables and 2 equations. Okay, I technically have x and y here. I've got a y, linear y right there. And then I've got a quadratic version of y right there. And I've got a quadratic x there. So I actually wouldn't want to try to solve this by elimination method, because I'd have no way of eliminating the x squared using only an x, all right, because those are technically not like terms. I'd have no way of eliminating this y squared term because I don't have a y squared term down there. I could eliminate the these y's if I found opposite coefficients and added these equations together. But elimination isn't going to work well in this case because I'd have to make sure that I could at least eliminate either all of the y's, all right, or all of the x's in one of the equations, okay? Otherwise, I'm kind of would be stuck at a dead end. So I'm going to solve by substitution. And I think in order to do that, I'm going to solve this first equation for x. And then once I get a revised equation, I'll just plug that in for the x up there. So I think that's my plan. So I'm going to add 3y to both sides and add 3 to both sides. And I'll get x equals 3y plus 3. So here's my revised equation, and just so you guys know, I'm solving by substitution is what I'm doing here. So if this, all right, if x is truly equal to 3y plus 3, that means I can plug that in to the contents of this x. All right, so I'm not replacing x squared with that, I'm replacing x with that. All right, so let's do that old substitution. So 3 times 3y plus 3 squared plus 2y squared minus 54y minus 143 equals 0. I'm just realizing now it may have been easier for me to solve this by solving for y and substituting for y, because then I'd have, well, no, I think it'd just be as complicated in this case, but that's fine. So, all right, so now notice, what do I have here? I've got an equation, all written in terms of y, which is good, all right? One equation, one kind of variable, even though I've got both linear and quadratic variations of it. So let's try to simplify this, and one of the things I want to point out that would be super illegal is this, all right? That would be super wrong, all right? Cannot distribute an exponent over addition or subtraction. So I'm going to have to figure out what is 3y plus 3 all squared. I could multiply 3y plus 3 times another set of parentheses 3y plus 3, or tell you what, I'm going to use a pattern. I don't know if you guys know this, but a plus b all squared is equal to a squared plus 2ab plus b squared. Oh ho ho! All coming back to you. So let's see, 3 times. Well, a in this case is my 3y. All right, a is 3y. B in this case is 3. So I'm just going to plug in for a's and b's in this equation is what I'm doing, okay? And if you're not familiar with this equation, check out some of my other videos. I think if you probably search something like special products or patterns or stuff like that, some of my Math 3 videos are all hit a lot of stuff on that, so if you need some practice. 3y squared plus 2 times 3y times 3 plus 3 squared, right? So I've plugged in all the a's and b's, and the rest of this is the same. 2y squared minus 54y minus 143 equals 0. Zero. So let's simplify that. So that's 3 times 3y all squared is 9y squared plus 2 times 3 is 6. 6 times 3 is 18. Then the y hanging out. Plus 3 squared is 9. Plus ... equals 0, right? I'm just simplifying over here first. I don't feel like rewriting that over and over. Now what do I do to simplify? Distribute. So let's see, 3 times 9y squared is 27y squared, plus 3 times 18, 30, plus 3 times 8 is 24, 54y. Is that a 54y? Oh, no they didn't. What? And 3 times 9 is 27. Let's see, and now I'm going to write out the rest of this. 2y squared minus 54y minus 143 equals 0. Now, so behold, I've got a quadratic equation. All right, you might recall from Math 3 that quadratic equation is going to have as many as 2 solutions. That's right, check that out, as many as 2 solutions. What? So that's related directly to this possible scenario that we were describing. All right. So let's go through combined like terms first of all. I've got this y squared term and this y squared term. All right, so that combines to be 29y squared. Okay. Now I've got 54y to the first and negative 54y to the first. Those guys kind of cancel each other out, which is really convenient for us. Super convenient. That actually makes this problem a whole degree simpler, I'd say, almost, if that makes sense. I don't know. Let's see. Then I could combine my constants. 27 and negative 143. Uh-oh, I'm already scared. Let's see. 143 minus 30 would have been 113, but then I'd add 3 to that. 116. Is it negative 116? Anyone checking me on that? 143 minus 27, bam, yeah, 116, and it takes the sign of the more influential one, negative there. Oh man, guys, we're so lucky that our linear term disappeared. If I had like even just like a plus y here or something like that, if these guys didn't cancel out, I'd end up having to solve this equation either by factoring, completing the square, or quadratic formula. But because I just have a squared term, check this out, I can just isolate this y squared and then root both sides. So plus 116 plus 116, and I'll get 29y squared equals 116. I'll divide both sides by 2. NT9, 2 NT9, that's what I said. Oh, I remember when I was 29 years old. I'm 30 now, guys. 116 divided by 29. My wife's actually turning 30 next week. Probably should do something good. I don't know. I actually already bought her present like 4 months ago and gave it to her. Does that still count? I don't know. So let's see. Y equals plus or minus 2. Okay, what were we solving again? What is y? What is this related to? This is related to an intersection of an ellipse and a line. Okay, so what that means is I found like the y coordinates of my 2 points, but I still need to find x coordinates, okay, of those points, right? Because just the y coordinates aren't sufficient to know the intersection. So how could I find the x coordinates? What do you think we would do?
Plug y in.
Yeah, let's plug it in, and in fact, let's be clever about it. Let's plug it in to one of the equations that just has x and y in it, and better yet, why not just plug it into this revised equation? So x equals 3y plus 3, so I'm going to have 2 cases of that. X equals 3 times 2 plus 3, or x equals 3 times negative 2 plus 3. All right. So this is the situation where I had something comma 2, and this is the situation where I have something comma negative 2. All right. So I'm finding both points x coordinates. All right. I just want to be explicit there. X is equal to 6 plus 3, so I get x equals 9. And this is specifically only for the y equals positive 2 situation. Over here I'll have x equals negative 6 plus 3, and x equals negative 3. And that is specifically when y was negative 2. So my solutions are 9 comma 2 and negative 3 comma negative 2. All right. And if I had more time, I'd actually be interested in going through the steps of graphing these using technology and showing that those would be the intersections. So I've got 2 intersections, so it's this situation here, and I was just able to find both coordinates, all right, of both points. All right, so that's what that represents. So that's kind of cool. So that would be valuable if, say, you were, I don't know, worried about a comet that was like had an elliptical path, and like we're on planet Earth and we're like, oh no, and then we had like some cool line laser thing that we could shoot that would go bzzzt, and then we found out what two intersections that would be. So then we could then work our way back and figure out, okay, when do we have to shoot our giant laser to protect ourselves from the elliptical comet? I don't know. There you go. This, guys, hopefully this video is still available when people need to save the world hundreds of years from now from a comet. Please find this video. I'll have to just add that as a tag. Save the world as the YouTube video tag. Bam. That'll be good. All right, let's look at one more situation. So technically, I want to point out, we found the intersection between a conic and a line. So that's not quite a system of conics. So let's do an actual system of conics. All right. And I'm going to get as far as I can on this. I think we'll have time. I think we'll have time. All right, so let's see. Solve the system. Let's see. Find the intersections is what that would also mean. Okay, so suppose I've got two equations. Let's see, do I like that? Yeah, that'll do. That'll do. Say I've got 9x squared. We'll do a nice simple one. Plus 25y squared equals 225 is my first conic. And my second one will be x squared plus y squared minus 2x equals 15. So, all right, looking at the first one, I've got two squared terms, so it's not a parabola. The signs of those are the same, so it's not a hyperbola. The coefficients of them are not equal, so it must be an ellipse. So, ellipse. All right, I'm just trying to walk us through explicitly that analysis of a general form, which is something that I want you to be able to do. All right, there will be questions on the test in the future of like, here's a general form, what type of conic is this? All right, so looking at this equation, let's see if we can figure it out. I've got two squared terms, so it's not a parabola. Their signs are the same, so it's not a hyperbola. And their coefficients are also the same. They're both positive 1, so it must be a circle. All right, so side note, how many intersections between an ellipse and a circle could happen? Let's see, I could have an ellipse like this and a circle like that, like Saturn looking thing, and I'd have 1, 2, 3, 4, okay. Could I have two intersections? All right, so I could have like a, I don't know, like, I could have two intersections. Could I have one intersection? So here's my circle. They would have to actually be tangent to each other. All right. That's kind of an angled ellipse. We didn't do too much with those. Could I have three intersections? We've got someone saying, yup. What if it was internally tangent and then hit those points as well? So I could have three. And could I have 0? Yeah, I could have like a circle, and I could have a little ellipse on the inside. I could have the ellipse way over here, right? They could just be completely unrelated. So yeah. So I could have 0, 1, 2, 3, or 4 points of intersection. The 3 one I like the best. That's kind of a harder one to have necessarily thought of right away, right? The more creative one, I guess. So okay, so looking at these, I just want to point out, I wouldn't use substitution here. I don't think. Because check this out. Let's say I solved for x squared, and I got x squared equals all these guys on the other side, right? If I plug that in here, I would get an equation that still had y's and x's. That wouldn't be helpful, okay? I could solve for y squared, and I'd get these moved to the other side. Oh, actually, that one would work. Aha, okay, all right. So that's where this analysis makes sense. Because this would be written all in, y squared would be in terms of x's, right? There'd be x squared, there'd be an x over here and a constant. And if I did plug that in here, I'd have x squared and then I'd have x's. So I actually could do substitution. That's pretty cool. All right, that's good to know. And if I solve for this x, there's not even anyone I could plug it in here directly. I could plug it in there, but then I'd still have the problem of, oh, I've got x squared and y squared, and this y squared is there. It wouldn't be helpful. So if I was to do substitution, actually, let's make point of that. So you could subs where you solve for second equation's y squared. You could do that. I'm actually going to choose to do elimination in this problem. If I choose to use elimination, check this out. If I eliminate both x's, all right, I would still have a y squared, and this x would either be introduced in there or it would stay in here, and I'd have an equation with y squared and x. All right. If I eliminate the y squareds, I'd have an equation in terms of x only, right? Even though it's x squared and x, so that would be solvable. And if I tried to eliminate the x's, there isn't even an x over here for me to eliminate, so that doesn't even make any sense. Okay, so if I chose to eliminate, I could eliminate the y squareds. Okay, so knowing kind of which strategy to use is valuable. Because we just did the last problem kind of using substitution, I'm not going to do that. I'm going to do elimination just to show us. So to get opposite coefficients for the y's, what would those opposite coefficients have to be? Yeah, between 25 and 1, I'd have to have 25. So I'm going to multiply this bottom equation by negative 25 is what we'll do. And let's see if I can actually do this math. So negative 25x squared, negative 25y squared, and plus 50x equals, and 25 times 15, I didn't have to memorize that one in 3rd grade, guys. Negative 375. Aha. So, and now what do? I add them up. So I'm going to add the first equation to this new third equation, I guess. So 9x squared and negative 25x squared is negative 16x squared, I believe. 25y squared and negative 25y squared is 0. Haha, hooray. Let's see, no x's plus 50x is plus 50x equals, and 225 and negative 375 is going to be negative 150. Okay, so check out what I've got here. I've got a quadratic equation, all right, because it's got a squared term. So I could solve this trying to use factoring. If I brought that 150 to this side and tried to factor to solve, which would be a lot of work, I could use quadratic formula. I could also use completing the square. I think I'm going to use completing the square, but the first thing I realized, I just noticed that all of these are even. So I'm going to divide through by something. I can't divide by 4 because 50 is only going to divide through once. So I'm just going to try to make these numbers a little bit nicer to work with. This would not have been a required step, but this is just like, hey, why not, right? Make it smaller numbers. Smaller numbers can math better. Put that on a t-shirt. So, looking at these, we've been masters of completing the square lately. I'm going to complete the square. That's what I feel like doing. So in order to do that, I'm not going to take out the GCF. I'm going to take out the leading coefficient of these two. So I'm going to factor out a negative 8. Let's see. So negative 8 times x squared. Ooh, that's ugly. But that's okay. We're fine. How many times does 8 go into 25? Negative times? Negative 25/8, of course. Ooh, man. Yeah, we're going to brute force our way through this problem. Maybe quadratic formula would be better. I don't know. It's fine. Doesn't matter to me. Let's see. So let's find our new C term. How do I do that? I take b, I divide by 2, and square it. This is going to be gross. Negative 25/8 divided by 2 and squared. That's the same. Dividing by 2 is the same as doubling the denominator there. So that's going to be negative 25/16. Man, that's so weird that both of those are already like squares. So 25 squared, what's that? 225? 625. What am I saying? 15 squared is 225. And 16 squared is 256. So I'm going to add this number to both sides. Oh, guys, this is gross. Also, I don't think this problem's factorable, just so you know. So quadratic formula would have been your other technique, in which you would have added 75 over here, and you would have just... Yeah, I will end up doing some more work in just a moment here. So let's see. So I'll have negative 8. I guess I could have divided that by 8 now. Is that what you're saying? Oh, you got me good. You're right. Right. So adding this in the world of parentheses was really subtracting whatever 8 times that is. 8's going to reduce that partially. 256 divided by 8 is 32. Good call. And it's subtracting now that I'd have to do. Wait a minute. Whoa, wait, what? Say what? Wait a minute. No, we're okay, because we're going to divide by a negative later. I thought I was going to get a negative over here and have to take a square root, and I was like, that's imaginary. That would have put me in the no solutions category, and I was pretty sure this one had a solution. So negative 625 over 32 is what I get when I cancel 8 with that denominator partially. Okay, good catch. Thank you for helping us. That was a really good save. You just made this video more valuable, because otherwise it would have been like just wrong, and that would have been not happy. So let's factor this. So this is negative 8 times x with a what squared equals, well, let's see, that what would be this thing, negative 25/16, equals, and over here I'll need to find a common denominator. So I'd have to multiply 75 by 32. I'm just going to, 75 times 32 is 2400. It's negative, and get the 625 combined with it. And I'm going to have, this is negative 3025 over 32. Okay. So let's see, next thing I got to do is get rid of this negative 8, so I'm going to divide both sides by negative 8. And I will get x minus 25/16 squared equals, the minus signs cancel out, and this will be fourths, because the 8 will cancel. Wait. No. It'll, no, it'll multiply that denominator by 8. Sorry. 32 times 8. It's 256 again. Oh, that's odd. And now I would root both sides, plus or minusing, not forgetting it. Okay, so the fact that I'm plus or minusing is immediately putting me into a category where there's at least going to be 2 solutions here. Now let's see, class is over in about 20 seconds, so you guys can actually start packing up and find the internet homework online thing. But I'm going to keep teaching this. I'll let you just kind of realize where I'm going. I'm going to end up getting solutions for x and then plug them back in to find y later in just a moment. So, all right, let me keep going here. Thanks for hanging out, guys. X minus 25/16 equals plus or minus, is that a perfect square? No, it isn't. 30/25. Oh, wait, it is. Really? Wait a minute. Really? And the square root of 256 is 16. And then I would solve for x by adding the 25/16 to both sides. 16ths. So I'm going to get 2 solutions for x. One in which I get x is positive 55 plus 25, so that's 80/16, which reduces by 4. 80, no. Actually, does that reduce completely? It does, doesn't it? 5, yeah. 16 does go into that. 5 times. And the other one, I get x equals negative 55 sixteenths plus 25. So that is going to be, what is that, 30 sixteenths? Negative 30 sixteenths. Which ends up equaling, both of those are divisible by 2, so negative 15 eighths. So these are two possible x coordinates of this conic section. And now what I'm going to do is, I've got the values of x. I want to figure out what y is equal to. The best place probably to plug those x's is in this equation here. I could plug those x's in here, and then solve for y. And I'm going to be square rooting when I do that, so it might even happen that I end up with 2 more solutions, putting me in this situation. It's not guaranteed yet, though. So let's see, x squared, y squared, negative 2x 15. Let's see, I guess I'll draw my classic little arrow here, just to make it super explicit that we're substituting. Here we go. And plugging it in all the way up top here for those x's, right? So x squared plus y squared minus 2x. So I'm plugging in x squared plus y squared minus 2x equals 15 is where I'm plugging them. So I've got 2 situations, one in which I'm plugging in 5. So 5 squared plus y squared minus 2 times 5 equals 15. And the other in which I'm plugging in negative 15 eighths. So I'll have negative 15 eighths plugged in for x plus y squared minus 2 times negative 15 eighths equals 15. So I'm going to work with both of these. I just want to point out that this is the one in which I've got 5 comma something as my solution. This one is the one in which I have negative 15 eighths comma something as my solution. Okay. So let me keep going here. Simplify. 5 squared is 25 plus y squared minus 10 equals 15. Hey, it's a quadratic equation, but there's no linear y term, so I'm just going to isolate the y squared and then root both sides. So subtract 25, add 10, and I will get y squared equals 15 minus 25 is negative 10, plus 10 is 0. What? Check this out. So when I root both sides, I get plus or minus the square root of 0. So I get 2 answers, but really it's just 1. Y equals 0. So I get one of my solutions is going to be 5 comma 0 is one of my solutions. All right? And now let's see what happens here. Negative 15 squared, let's see, let me draw a line down here just so it minimize confusion. Negative 15 squared is positive 225, 8 squared is 64ths, plus y squared equals, let's see, negative times a negative is positive, 2 partially cancels out with that, so that's not equals, that's going to be plus 15, 2 and that is 4 equals 15, all right? So same thing, I have no linear term, so I'm going to subtract these from both sides, and I'm preemptively realizing that I'm going to need a common denominator to do that. 64 is the one I'll need, so I'll multiply that by 64 over 64, and this I'll multiply by 16 over 16 there. So I will get y squared equals, let's see, 15 times 64 is 960. 64ths. I'm subtracting 15 times 16, which is 240 64ths. And I'm subtracting 225 64ths. All right. Whew. All right, here we go. So I've got y squared equals, let's simplify this, 960 minus 240 minus 225. I get 495 64ths. This is positive, so that means I'm going to get a real solution here. So I can root both sides. I'm just recording a video still. Come on in though. So root both sides, plus or minus. So I get y equals square root of 495, I believe, is divisible. It turns out 9 goes into that, so plus or minus let's see, plus or minus the square root of 9 times, and it goes in 55 times. Square root of 64, hopefully you guys know, is 8, and y equals plus or minus 3 roots of 55 over 8. So I get two solutions there. And when did I get those solutions? When I plug in negative 15/8 for x. So my other two solutions are negative 15/8, comma, 3 roots of 55/8, and I've got the one where I got negative 15/8, and the negative version of that, negative 3 roots of 55/8. So it turns out the solution I have is one in which, let's see if I can focus on this, in which this is my graph. So it was one in which I had 3 solutions, which were the ones we just mentioned. All right, so kind of an unusual case, intersection between a circle and an ellipse. 3 solutions, you can see there's the 5, 0, and then negative 15/8 up 3 roots of 55/8, and negative 15/8 down 3 roots of 55/8. So there we go. So thanks for watching, internet friends. Have a great day. Bye-bye.